you very much. In which case, yeah, good afternoon. Thank you all for joining today's session. So this is the 12th in a rolling series of webinars hosted by the Emerging Areas team here in the Energy Sectors Group. My name is Johnny Bland. I'm also a member of said Emerging Areas team, where my principal focus is on sort of partnerships and market development. And it's in that context that I'm delighted to be the moderator and the facilitator of today's webinar. We'll shortly be hearing from Emerging Areas Director Cindy Tiango, but before we do, you'd all sort of see or have seen a QR code up on your screen. We'll be using this to sort of gather some audience feedback at the start and the end of today's session, and I'd be really grateful if you could fill it in while we sort of wait for people to filter in and before we kick things off in earnest. But before we do so, I'll share a little bit about today's webinar. So this session brings together or brings to ADB the Energy Systems Catapult from the UK to discuss their role in accelerating innovation across the energy system, and also to highlight their flagship program, so Innovating for Transport and Energy Systems, which recently concluded in India. Participants will also hear from two UK innovators, AIM Group and Iron8, who are currently working to develop their international markets with support from the Catapult. And we'll also hear a little bit about how their technologies can benefit ADB DMCs, both on the software and on the hardware side. And my hope is sort of over the course of the next hour or so, you'll all gain insights into sort of some successful methodologies for developing solutions using a combination of sort of in-country resources, but also international collaboration, a broader understanding of the innovation ecosystems between partner countries, which I think is something that's particularly relevant for our DMCs. And alongside that, new innovations and how they can be supported to access markets and provide rapid change in the energy sector and beyond as well. And there'll also be a Q&A session towards the end of the webinar, so please do jot down any questions for our speakers as we go, or leave them in the chat, and you'll have the chance to ask them essentially of our presenters and speakers later on. So without further ado, I'll now hand over to the Emerging Areas Director, Cindy Tiango, who will now deliver some opening remarks before we then move on to the webinar proper and hear from today's speakers. So Cindy, away you go.
Thank you. Thank you so much, Johnny. Good afternoon, good morning, good evening, everyone. I'm excited to open this very exciting webinar on innovations in the energy sector. So around the world, the innovative ideas and technologies are being developed to achieve net zero emissions while improving energy access and security. Many of these solutions are complementary across countries, and by combining strengths and sharing knowledge, we can accelerate the development and deployment of clean energy technologies. Supporting such innovation requires more than traditional incubators or accelerators. It calls for environments where learning is shared, insights are exchanged, and real needs are identified. All these while ensuring that innovation efforts are focused where they matter most. At ADB, we play a key role in catalyzing and channeling funding toward these collaborative efforts. Through our developing member countries, or DMCs, we help create lasting benefits for people in the region while advancing technologies with global potential. In today's webinar, the Emerging Areas Energy Sector team is delighted to partner with the UK Energy Systems Catapult, who will showcase cutting-edge energy system technologies and demonstrate how these innovations support net zero goals and inclusive energy access, particularly for ADB DMCs. Established by the UK government, the Catapult network connects academia, industry, and government to move great ideas from research to real-world application. Its mission is to accelerate innovation across key sectors and foster international partnerships that bring these solutions to broader markets. We hope today's session offers valuable insights for our ADB colleagues and participants across the energy, transport, markets, and private sector teams, and show how local strengths and global collaboration can come together to drive innovation. Most importantly, we look forward to deepening collaboration between ADB, the UK private sector, through the Catapult, and our DMC partners to accelerate net zero energy solutions into your respective projects and create lasting, sustainable impact across the region. So welcome to this webinar. Over back to you, Johnny.
Fantastic. Thank you very much, Cindy. So I'm now going to be bringing in the lead from the UK Energy Systems Catapult, Andrew Pease, who will now talk a little bit about what he does, his work, and how it can benefit companies across the private sector. So, Andrew, please to come in.
Thanks, Johnny. So I'm now going to hopefully show my command of technology and share some slides. But really happy to be with you guys today. Really sort of excited about the opportunity to talk about what the Catapult does, but also some of the innovations that we support as well. So what I'll do is I'll go through a brief introduction of Energy Systems Catapult, who we are, what we do, and then we'll talk a little bit about our Innovating for X program, and that relates back to the Innovating for Transport and Energy Systems initiative that Johnny referenced earlier. So who are we as the Catapult? So Cindy has already referenced the Catapult network, and has done so very eloquently and very well, so I don't need to spend a lot of time on this slide. But we're a network of 9 catapults focused on different sectors. So you see them listed down the right-hand side of the screen there. So we are Energy Systems. We're focused on decarbonization and energy security and providing the acceleration for innovation in that sector. We also have sister catapults in offshore renewables, satellite applications, high-value manufacturing, digital, cell and gene therapy, connected places, compound semiconductors, and medicine discovery. So we cover a wide area of expertise from the UK. And what we're looking to do is create opportunities, but primarily we're looking to help solve problems. So understanding the needs and then helping to solve those needs through technology and other solutions. So when I talk about Energy Systems Catapult, we have a variety of experts based in our head office in Birmingham. It's important to stress we're an independent not-for-profit. So all of those catapults that I listed previously, they're all independent of each other. We do receive some funding through Innovate UK, but we're also independent of Innovate. So we're not a government body, we are an independent entity. But our focus is on driving impact, driving change, and creating a better energy system for the future. So how do we do that? So we do that through a variety of capabilities. So we have a variety of modeling capabilities. We work with systems and clean technology engineering. We work on our data platforms, and we've done a lot of work in the UK focused on data and digitalization. And we also provide evidence to policy. But the thing that I'm going to talk to you about most today is our SME support, our innovator support program. So that is focusing on how do you get innovations from the UK and from other regions of the world to actually deliver impactful solutions in target markets. So I will jump straight away and we'll start to talk about Innovating for X. So this sounds very much like a sort of a bit of a potentially a spy title or otherwise. I don't know if it might be a bit grand. But what we do here is we're looking to understand the challenge. We're looking to bring together the right solutions. So it's a structured, collaborative approach to bring together startups, partners, and stakeholders. So that is looking to co-develop and pilot solutions to address specific environmental needs. So that could be at a city level, that could be at a region, country, even across a region. So we, you know, I'm in Singapore, and I'm hearing a lot of talk around the ASEAN grid. So how does that necessarily come together? Where are those innovations required? What we try to do with the Innovating for X platform is look at sort of one approach, many applications. So where are the needs? Are they in transport? Are they in flexibility? Digital and AI, grid integration. And this is just a list of some of the areas where you can focus. But what we do is we then start to look at the bespoke environmental challenges. So what's specific within the region that we're looking at? And I know the ASEAN region covers a wide range of particular different demographics, different geologies, different climates. So every time we're looking at a region, it's all about understanding those environmental challenges. Then it's starting to identify the innovations and the collaborations that can start to showcase those products and services in a real world context. I will keep emphasizing this. This is about generating real application and real solutions that actually make change. So then how do we make those connections, bringing those firms to collaborators within the marketplaces that we're targeting? So how do you start to bring those in-country partners into the program so that they're working alongside the innovations? And ideally, you have multiple innovations working alongside each other. This is all about developing those partnerships and that framework for collaboration so that you can then, off the back of that, start to make the evidence base to policymakers and investors that starts to inform the interventions and deploy the capital more effectively, and also deploy government funding more effectively and with more impact. So I've sort of alluded to this, but this is a bit of an idea of the roadmap that people go through. So typically we'll start by selecting the region that we want to focus on. We then carry out a sort of challenge assessment, so understanding all the stakeholders involved, the whole system's challenges that are involved, definition of the innovation priorities. And after we understand the priorities, we can then start to look at the innovators that we're going to identify. So start to scout across UK markets, look at what's already happening within the region that we're targeting, and start to put a program together around bringing those solutions together to start to deliver some growth. So that can either be done through one-to-one sort of support, so incubation accelerator type support, or it could be through sort of specific masterclasses and education on specific areas that are sort of common across the cohort. But our end goal is always to drive towards pilots and demonstrations of these technologies, and then ultimately to go from those pilots and demonstrations to enable the funding, enable the finance that lets them go to scale. So how do you start to put these in a position that they're eligible and they're financially viable for debt finance or equity finance or other funding that can then start to accelerate them at large scale? So why does it work? So ultimately, that systemic approach. We are the Energy Systems Catapult. So we are focused on a whole systems view. We're not looking at a single vector. We're trying to understand everything that comes together, and that includes policies, markets, consumers, understanding the real barriers for accelerating innovation. It's all about collaboration. So how do you bring the target countries, the target regions together so that everybody benefits from the program? And we're not just looking to do a single support for one company and that one company benefits. We're looking for a larger scale benefit from this. And we get that through collaboration. As you start to build this out, you also start to create markets. So as we're able to inform policies and we're able to inform market shapes and activities, you start to create marketplaces that enable decarbonization, that make value for decarbonization. Now, we are a UK organization. We have received some funding from UK government. So there is always interest for us in terms of where those UK innovators then start to be able to access the markets. But it always works better with a local partner. So it's always about getting mutual benefit from the program. And then finally, again, going back to that evidence-led decision. So whether that's policy or market or consumer decisions, understanding what the impacts are of their choices. Some previous Innovating for X programs. So this all started with Innovating for Clean Air, which was a program ran in India and culminated with a Bengaluru testbed, which was on Church Street. And so they basically went emissions-free across that street for a week at the culmination of that program. We've run Innovating for Net Zero Buildings here in Singapore, and that was a large program bringing innovators to Singapore and pairing them up with corporate partners. We've done work with Brazilian utilities, understanding their innovation needs, and then starting to fill in the gaps with innovation companies that can help support those needs. And finally, and the big flagship program that we've run is Innovating for Transport and Energy Systems. So this was a 3-year program led by Energy Systems Catapult and India Institute of Science. And this program was looking specifically at the impact of transport on the energy systems within India. and bringing organizations together from both countries to address them. So it's supported over 50 SMEs. It's been various R&D and market exploration. And now more than half of those companies are partnering with each other to deliver solutions. Large-scale demonstration projects have been enabled, and there's large industry collaborations that have started to develop with companies such as Tata Power and Motorvolt. And that, you know, it's the biggest program we've done, but there's also the largest impact that we've delivered through that. So that's why that's an area that we really like to focus on. So when we talk about ADB and your mission, what we're thinking here is, or you know, why we want to bring this principle to you and kind of talk to you about it today and hear your questions as well, is we believe IFX really gives that opportunity to accelerate impact. So how do you start to leverage programs that really start to mobilize solutions and with measurable environmental, social, and economic impact? It's building those local ecosystems. So how are we, you know, whilst we're supporting other companies and other organizations to get involved, how are we also building that long-term capability within country? We will always work with these on local partners, and that's very important to us. Information around policy and investment. So again, we talk about how do you start to change markets, build solutions so that you're able to develop that longer term goal. And then that regional collaboration. So once you've established in one country, can you start to export that to another? Can you start to bring those solutions together into a whole? Can you start to bring other pieces of the puzzle together so that you can have increased impact? And it starts to grow exponentially if you start to get the right power behind it. So last thing I want to highlight, and I've mentioned this previously, so innovating for transport and energy systems. So we've supported over 50 innovators to date. It's generated around 12 million in commercial revenue from a £3 million program, but there's also other investments and other programs that have come off the back of this. But then there's also over 50% of the innovators have had a collaboration. The full impact report is on the link there, and I believe you'll have the slides shared with you after the presentations today. So more than happy for you to reach out and to ask questions after the presentation, but also my contact details are here. So if anybody has other questions, please feel free to reach out to me after the session as well. So I'm going to wrap there. I think, Johnny, I was about on time for you.
Yeah, just about to time, Andrew. So yeah, thank you very much for that. That was really, really interesting. And I've certainly noted a few questions that I'm really keen to ask you towards the end of the session to try and sort of draw out my own understanding there. But now, having heard a little bit about what the Catapult does and how it can support private sector businesses, we're now going to hear from a couple of the businesses themselves that the Catapult has been working with who are out in Singapore at the minute. So I'm now going to bring in Leo Older from AIM Group, who's going to come in and talk a little bit about what his company does and how they've worked with the Catapult and where their solution sort of fits in with what we feel or what they see as broader ADB DMC needs. So Leo, I'll now bring you in now if you're ready to bring up your presentation.
Brilliant. Okay, I'll just share my screen. Just let me know if you can see that coming through. Sorry, apologies. I will just have to open and reopen Zoom and then it should share through. Just give me 1 second.
We have Matthew waiting. Do you want to jump to Matthew while Leo's fixing his bugs?
Yeah, sorry. Was just about to jump in and suggest similar. So Matthew, if you're able to jump in and we can sort of swap around the order a little bit. So yeah, I'll now please do come in.
Yeah, mine seems to be working. Can everyone hear me okay?
Yep, fine from me.
Yes. Perfect. Good afternoon, everyone. Thank you for having us. I'm Matthew Williams, founder and CEO of iNet. And so we have a hardware backbone for the smart grid. And so to me, we're living in an era of quantum computing, AI data centers, and the electrification of everything. But the very system that powers all of this, the electricity grid, hasn't changed in over 100 years. We have more inefficiencies, more and more blackouts, and hundreds of billions in economic losses. I mean, we should just look at what happened in Spain and Portugal earlier this year. So how are we going to upgrade the biggest machine that's ever been made? And that's exactly what we do at INET. So first, we invented new hardware, a new building block. We call it the Hybrid Intelligent Transformer, or HIT. It's a drop-in replacement for a traditional transformer, but we've added a brain. So this gives us two things: real-time visibility and millisecond precision power flow control. So all of a sudden, this basic building block becomes like a Swiss Army knife, solving challenges not just for the electricity grid, but all the big things connected. Let me take you through a couple of use cases. Firstly, data centers. We all know the enormous growth that this sector is going through, and they're struggling to find fractions of a % improvement in energy efficiency. Our technology delivers a 5% improvement in PUE. On top of this, we provide perfect power quality, preventing issues that would otherwise damage equipment and cause downtime. We save money in CapEx and OpEx, amounting to tens of millions, and we even save space. Secondly, commercial industrial. Here, it's all about energy efficiency and power quality. So whether we're talking about chip fabs or process plants, our hardware goes in and prevents these issues, saving on energy bills and preventing these plant trips causing downtime. Our third customer type is the electricity grid itself. So we know that as we're adding more renewables, electric vehicles to the grid, this is causing issues. A lot of this is around visibility and control of the voltage within the network. To simplify, the grids are having trouble keeping the lights on. This is the problem that we solve for them. We're going into grids in Europe, working with partners like EDP and National Grid. And finally, renewables themselves. We provide the grid connection infrastructure, allowing them to connect, reduce their costs, and provide better quality power to the energy system. But once a HIT goes into the system, INET's AI-enabled software platform coordinates them in order to unlock a system that optimizes itself. So an INET system can have 33% more renewables and EVs connected, have 25% more power through the existing infrastructure, and a 6% reduction in losses. So one HIT goes in, solves a problem in the physics, but a smart connected network of them takes us closer to a flexible, resilient energy system that we need. And to have this impact quickly, we didn't want to build big gigafactories. Our partners, our customers come from very trust-based industries. So we work with existing manufacturers to build the bulk of our device. At INET, we supply them the brain, like the Intel Inside model. We're working with partners covering Europe, North America, and Asia. And to fuel all of this momentum, earlier this year, we closed our 13.5 Series A to allow us to accelerate, to modernize and reinforce energy systems. If we don't do this, we risk more blackouts like we had earlier this year in Europe. And avoiding risk is important, but equally important is removing roadblocks. We can't power AI without better energy systems, and power infrastructure is their biggest bottleneck, but it's our biggest opportunity. Thank you.
Thank you for that, Matthew. That was really, really interesting. And again, sort of sparked several questions that I'm really keen to ask you sort of towards the end of the session. But I'm now also, hopefully, if he's managed to solve his IT issues, going to bring in Leo Older from AIM Group, who can come and talk a little bit more about what he does, perhaps more on the software side. So a really interesting balance of two different kinds of solutions there. But Leo, if I've stalled for long enough whilst you get your PowerPoint up, if you're ready, off we go.
Lovely stuff. Can we see my screen?
I can, yeah.
Brilliant. Okay, so my name's Leo. I'm the co-founder of AIM Group. We are spun out of Imperial College London and backed by Innovate UK. And ultimately what we do and our goal globally is to reduce the long-term cost of any physical infrastructure. And that's exactly what I'm here to talk to you today, specifically in terms of energy asset integrity. But most importantly, we do that by preventing downtime of infrastructure and improving the operating efficiency using data that's already collected. So the idea is we take the existing infrastructure that we're building and the new infrastructure we're building, and we make it more efficient, more cost saving, and give it a longer service life. It's really critical as a developing nation to obviously have this infrastructure and make it last as best as possible. And that's exactly where we want to integrate. I think most importantly as well, I have the absolute pleasure of bringing some of the UK's best machine learning talent to solve some of the most challenging engineering problems. So we have a whole range of solutions we bring, but most importantly, whatever the infrastructure is, we always find the best way to get the most efficiency out of it, depending on the situations and the challenges it faces. So this is where our technology started from. This is a critical structure running along the UK, connecting England and Wales. This is the structure we can't have close. It links two countries. It's really important. And with traditional infrastructure, with traditional monitoring on the system, there was no way of keeping this thing open. It's been in use for over 70 years, and it's really struggled. People haven't been able to understand what it's doing, and we were looking at a £40 million replacement in the structure. What we managed to do is use our AI, understand what the structure is doing, and actually validate it and keep it in service. So a completely different outcome where £40 million has been saved just using the data that structure was already collecting. I'll go into a little bit more about what that data is and how it applies to every structure. But really, it's this dramatic impact of what we've been able to do and how we can apply this to any kind of infrastructure. So in terms of what we do, we apply machine learning to understand the true physics of a structure, find structural defects when they're small and manageable. And most importantly, this allows us to reduce maintenance costs by up to 65%, extend lifespans of structures by up to 5 years, and have zero false alarms. So we will find those defects, those issues, we will keep the structure in service, we will prevent downtime, and we will allow for preventative maintenance on any kind of structure. Ultimately, every structure we deploy on is a cash generating exercise. So whatever our software does, it's always insured so that it saves the client money at the end of the day. That's really critical in terms of how we deploy this. So in terms of what we do, we find these problems when they're incredibly early. So typically when a problem is found, it's found quite later on, and it's a lot of cost. What we can do is we can find that very early on when it's about a hair's width worth of problem. We will find and understand and learn the future behavior of what a structure will do to 99.3% accuracy. And most importantly, we will give an understanding of the service life of that structure, what is left as such as we've managed as best as possible. For us, the name of the game is really about understanding a structure as best as you can, such that you can make the best management decisions and get the most use out of it in every single way possible. So in terms of what that delivers operational uptime and efficiency, preventing closures. As mentioned, we reduce maintenance costs and prevent that downtime. And most importantly, if a structure is designed for 20 years or 30 years or 50 years, we give it additional lifespan. So we provided that more time. And as such, we can really squeeze this for the most efficiency and performance. Most importantly, this technology can work on any kind of infrastructure or even subsystems or even a single sensor. People, when they talk about AI, they always try and go for scale and data. We take the opposite approach, which is that we want to learn something perfectly and then we can scale. Once we have a really good understanding, that's when we have the most power and the most capabilities to make a difference. Most importantly as well, this is all mapped, this is all put on the platforms. And as such, we can understand the structural change of all sorts of structures, prioritize them, and do this across an entire country. So it's really important when we're managing all sorts of assets and we have limited budgets. How do we make that go further? How do we use our existing infrastructure as best as we can and plan for future infrastructure and maintain that better? In terms of our core technology, all critical infrastructure, whether it's a wind turbine, whether it's a gas pipeline, whether it's a power generation plant, there will be some sort of measurement, understanding the condition of a structure. And this is sort of what it looks like. This is what engineers have to look after day by day. And it's really hard to understand what this is doing and when there is a problem. Typically, we're quite reactive. We find problems and we get downtime and a loss of efficiency. What we do is we take that, we learn the underlying physics of the structure, we learn exactly how it behaves, and then we can identify any deviations or validate that it's working perfectly. And as you can see there, that's exactly what we do. We apply this across any kind of structure as well. So the use case is absolutely massive across the energy sector. In terms of being able to do this, it's really critical that high accuracy is achieved. In most times, machine learning is used to correlate. For us, it's purely used across understanding the underlying cause of it. And as you can see in these examples, we achieve incredibly high accuracies. And we learn a structure incredibly quickly, such that if sensors are just installed as they're being built, we can already deploy straight away and get the results that are needed. In terms of where we can help, it is incredibly wide and incredibly diverse. So most importantly, we don't look for what is there, we look for what's coming and how we can best prepare for it. And ultimately, there'll be a lot of times where we can bring these budgets down significantly. In terms of further management and really to show off the capability of this system, this is traditionally the sort of data that would be given to an asset manager. What we can do is we can break this down further and we can really give them an understanding of what their infrastructure faces, how it operates, and the risks to it. And suddenly, what was quite a complex problem is broken down to its environmentals, its contributions, and ultimately you can see that there's one predominant factor driving it. The really critical point of this is showing the level of understanding and what we can get from data and how much more there is when you really understand what's going on. And as mentioned, we can do this at any scale. So currently we're on the world's most powerful monitoring system, and we can work all the way down to a single sensor. So the most important thing is that if there is a structure with sensor data, it's about getting that data, it's about understanding that structure as best as possible, and then bringing down its operating cost as far as possible. In terms of our industry adoption, we're adopted right across the UK. We've made significant impacts across every single industry and really made, I would say, a significant change to how infrastructure is managed and maintained in the UK. And most importantly, we want to be doing this on new structures because that's where the most value is gained across the entire lifespan. In terms of the capabilities we bring, traditional structures have a very important use case in terms of having monitoring, but the level of capability that we bring completely changes that and changes the paradigm of how this is managed and the efficiencies realized. Most importantly, AIM is the only company worldwide to be able to have this technology right now and to be able to bring these sort of capabilities. We're very keen to talk about all sorts of infrastructure, whatever the problem is. Like I mentioned, we've got a very good world-leading team of machine learning engineers that can solve any kind of critical problem and realize any kind of efficiency, whether that's infrastructure, whether that's what the structure faces, or whether that's other sources of data being collected. The ultimate case is really understanding behavior and really understanding how we can get the best out of it. Brilliant. Thank you very much.
Thank you for that, Leo, and thank you, Andrew and Matthew as well for your presentations. Some really interesting stuff there. And that feels like a sort of, I said I had some questions for all of you, and I think that feels like quite a good segue into the sort of Q&A section of this webinar. If you've got any questions for those of you in the audience, please feel free to stick them in the chat. I'm happy to ask them of our presenters, but I'll start things off with a couple from my side. So, Andrew, this first question I think is for you. It sort of covers two areas in particular, but how would you sort of define success in an innovation program more broadly, whether that's an international one, whether that's a domestic one, and I suppose what are the differences between the two for you as well?
Yeah, so I think that there's definitely one piece, well, one word that I think I used it quite a lot, which is the word impact. So we're very focused on how do we generate change through innovation. And I should probably emphasize positive change, but hopefully that was that's just implied. But it's how do we put in, and I guess the word I would probably add is sustain change. So doing a pilot, doing a sort of a one-off proof of concept demonstration, it's all well and good, but we want to see that be taken on. So how does that get adopted by industry? How does that get adopted by government in policy change or other funding mechanisms, etc.? How do we make sure that the changes that we can demonstrate and the innovations that we demonstrate really impact beyond just that initial sort of program? But I think when we look at it in the UK, obviously it's a very much focus on that area, but I think the other piece when we do international is how are we working with both countries or both regions together? So we're not just that we're sort of supplanting one idea into a country, but it's how are we enabling growth of ecosystems, growth of insights, so that the countries that we're working with, and even the UK in many instances as well, can learn best practice, they can learn the best ideas, they can figure out new ways of doing things and adopt those into the solution. So again, it comes back to that sustained impact, but through sharing of knowledge and development of ecosystems that actually enable these things to go. And then that secondary sustained impact is that those in ecosystems allow it to happen again and again and again. And so therefore, that's where working with, organizations like ADB and other organizations that bring those sorts of funding power behind things, we provide that solution that people can go, oh yeah, we want to push that further, we want to take it on. And we're not, we're in a pull environment rather than necessarily pushing solutions.
Yeah, thank you for that. I think that makes complete sense. It's something with huge relevance for this part of the world as well. I've got another couple of questions. So Leo, I'll probably move into a quick question for you now as well. So I think my first question really sort of talked a lot about data throughout your presentation and the use of data, but I guess for me, it'd be really good to hear about how you use data to drive your decisions, particularly in this part of the world, sort of Southeast Asia, where data isn't always as widely available as it might be elsewhere. Just really keen to see how you see that applying to this market as well.
Brilliant. Well, there's a common phenomena in machine learning and understanding things, which is we'll take some sort of AI and we'll have some sort of data set, and then the AI won't understand it very well. And then we'll say there's something wrong with this data. We need more data. And fundamentally, the entire AI industry has a problem, which is actually it's the AI that is bad. What we want to be doing is making really good AIs and working with whatever limited data there is. The most important thing to us is that we don't install new sensors, new data sources, because ultimately that costs money. And we want to deploy and realize results straight away. So the most critical thing we work on is really understanding the fundamentals and really having a really good AI architecture, such that we can do some incredible learning, have some incredible results and outputs, and ultimately use the pre-existing data sets. And it doesn't matter how big or small it is. I always say in terms of AIM, we operate on the world's most powerful monitoring system, but also the world's smallest monitoring system, which is a single sensor giving a single output of data. But if you can understand it at that level, you can scale to any level and you can do anything you want with the data. It's ultimately about realizing those relationships, the efficiencies that you can gain for your selected supplier.
Yeah, completely agree. I think that makes a lot of sense to me as well. I think ADB as a whole is making a very big push for sort of quality solutions and the integration of quality into their projects and into the things that they deliver. I suppose the sort of second question that comes to me off the back of that is, are you seeing pushes sort of elsewhere in other bits of your work for a much stronger emphasis on quality and longevity and when it comes to infrastructure? Yeah, it'd be good to hear your thoughts on that as well.
100%, yes. You see it everywhere, ultimately. The thing is, as well, as soon as we deploy and we show you the capability to solve a problem and really understand a relationship, the thing that changes is it might start off as structural, but they might come to us with further problems. And it really is just about understanding them. I'll give an example, which is we were working on wind turbine solutions. The idea being that we can de-risk this wind turbine, we can up its load, and suddenly we can give it a software update such that it's generating more power out of the exact same bit of infrastructure. So really a massive gain in terms of efficiency because nothing new is being built. It's just a software update. The thing we started looking at next was in terms of the battery systems linked to it. And again, this is completely different, but ultimately all the fundamentals remain the same, because understanding relationships. And what we were looking at was understanding battery fires and actually preventing them and spotting them early. So again, a completely different use case, the same AI architecture, but actually it's about the data's already there. We've got something there and we can really build some quality to expand the use case.
Yeah. Again, really interesting stuff. I've got loads more questions, but to be honest, it's now the time for the audience to sort of ask a few. So I will open things out. If anybody in the room, online or in the chat has any questions, please do put them in and I'm happy to ask them to our presenters today.
In the audience.
And if no questions at all, I'll assume both the presentations were perfect and were very, very clear and everybody's all on board.
Maybe I'll venture to ask a question.
Go for it, Cindy.
Yeah, admittedly, these are all highly technical and you know, both solutions are highly technical and probably way above our heads, my head definitely. But I was just thinking, a question to Leo on this AI predictive monitoring solution. I was wondering how with all the integration of renewables, variable and intermittent renewables into our systems, is there an application for such a tool or solutions, AI-enabled solution?
Absolutely. I mean, the name of the game remains the same, which is understanding the relationships between them and where you're going to find the most efficiency. Let's take an example such as energy mix, for instance, where you've got X amount of solar, X amount of wind, and you've got different costs between them. Ultimately, this isn't going to be a use case of one thing means another. It's going to be many different things: solar mixing with wind, mixing with time, mixing with cost, and it's about understanding all these different complex factors and how they come together. And that's really what we do. It's about establishing those really, really complex relationships and understanding how they interact, and ultimately being very convenient for the person making the judgment. They don't want to be judging between 20 different variables. They want to know the answer and have the evidence in front of them. And that's exactly how we want to be harnessing AI, is to have true understanding and then a very useful output. And it's something we always say, which is you want to be able to manage whatever system you have in a cup of coffee. That is always our target. So it should be simple, it should be intuitive, and it should be easy. And
Andrew, I know you'll probably have views on this as well, so probably a good time for me to bring you in here. But yeah.
Yeah, so it's an interesting point, and I'll start with a comment which was made by the mission director for Green Power Future Mission in MI on an AI session, and his comment was, the power sector's been doing this for decades, we just called it big data. But I think what Leo is alluding to there, though, is absolutely critical, and it's somewhere that the Energy Systems Catapult looks very closely, is we're dealing with a very large system. And it's something that, as sort of from a human brain perspective, it's very difficult to deal with. So if you look at where systems engineering is typically applied, they will do it on sort of aeroplanes and things like that, where there's a finite boundary of the plane and the air, and they sort of know what will happen. There is a growing piece now which is applying systems to energy, and that's a very, very complex space where you have to start to understand many variables. So if I start to push on the grid in a certain space, what does that do for me being able to produce, electrolyze hydrogen or produce other variables? What does that do for the consumers in the space? What does that do for the people at the end of the line? And then when they change behavior, what does that mean further upstream? So, we're starting to understand more and more that AI is becoming a real key piece, because that predictive component is critical, but that systems understanding the different variables within any given energy sector is absolutely mission critical to be able to find solutions, find innovations, and to find the right innovations to actually implement within a marketplace.
Yeah.
There is one thing I'll add, if I may, as well, which is not only are we dealing with a complex system, but we're also dealing with something which is an evolving system. And as we bring new energy online, and as we bring in new cities and new demands, there's something which is, we've been doing algorithms for a long time, but these things can't adapt and evolve in the same way in the many spaces that an ecosystem can of energy. And that's really critical. It's about understanding and having a system that can also evolve itself. And that's what, if AI is done correctly, that's what it's all about.
Yeah, thank you both. Cindy, please.
Yeah, just a follow-up question. I mean, there's also space for like ancillary services and how AI can be able to help, I guess, utilities, as well as the problem they have around so many renewables, a lot of faults happening, a lot of disruptions in the grid, and in fact, the grid can become obsolete with all of the self-generation that's happening in many places. So those are some of the problems that the energy sector is facing, particularly in energy generation and transmission. And I think, yeah, maybe INATE could also talk to that as to how the HIT is innovating on some solutions when it comes to faults, when it comes to integration of a lot of probably batteries, including from vehicles, because we are looking at a lot of vehicle grid integration right now. and how that affects the entire performance of a system.
So I'll jump in very quickly there, and I will apologize for Matthew. He's had to drop off and address something else. But so with the HIT and with that transformer, that AI piece of it and that implementation, and I've worked with Matthew for a while now, and I didn't quite realize until this week the AI component of what they're doing. So having one efficient transformer is great, but once you start to get a network of them, they can start to really make things tick. And then if something happens, they can adapt, they can move, and they can do it in real time. But I think the one thing that I've found, and with all of these solutions, technical and AI is absolutely at the top of the list, is it's all about applying it for the benefit of people and the environments and the space that they're occupying. So where AI is delivering a solution, and you know, there are some amazing people out there coming with some great ideas, and we've had two on this presentation today, and I'm, you know, ride their coattails quite happily as part of the Catapult. But you know, AI is there. It is a massive potential benefit for people. And it's all about making sure that it's pointed in the right direction and it understands the problems. Because, and Leo, I'll ask you a question here in terms of, if you ask AI the wrong question, how useful is it?
Oh, that's a very challenging question. If you ask AI the wrong question, how useful is it? I have to say, honestly, it really varies on what I would say is architecture. And it really varies on how resilient your system is and how much it understands what it's trying to solve for. So you can ask the wrong question and it can still take you somewhere correct. That's really up to who designed it.
Grayson, that's some question. We were just discussing about LLMs evaluating other LLMs.
Yeah, LLMs all the way down. But I think this is really interesting. The conversation about emerging technology, and I think now we're looking at digital substations and IEDs and digital substations generating data, and we're having, you know, it talks about virtual power plants and these pieces where I think for critical infrastructure, it'd be interesting to hear what is being integrated into the sensor and what is being considered, and how that can be interoperable with SCADA, like, you know, larger energy systems like this.
Brilliant. There's one thing I'll caveat on first, which is LLMs. LLMs are known as large language models, which are what's called generative AI. So that is something that adds data into a system, that creates things such as new words or whatever it is to give you an answer. And LLMs are really bad at solving any kind of problem. And I'm sure if you use ChatGPT for long enough, you'll definitely be getting wrong answers. So in terms of anything critical like infrastructure, it's really important to avoid using LLMs. It's massively important to have really good understanding and trust in your system. So there's something quite technical called CNNs that most people will be using, called convolutional neural networks. Those things will be getting relatively good answers. You know, you're probably getting 80% accuracy. And to really go higher, what you need is some sort of machine learning that understands the confidence in what it's learning. So it will take in whatever the data sources is, it will train on those, and it will give you, it will know when to train and when not to train in order to get the best accuracies. And that's one of the most technically challenging problems. But we've spent the last 5 years solving that. And once you solve something like that, you can pretty much open up your AI to any kind of data sets in that space, and it will be resilient and it will be capable. And to tie in a little bit earlier to Andrew's question, you know, you can start to ask the wrong questions, but the relationships will remain the same, and it will still be able to give you consistent answers.
I think I'll jump in as well. So your reference to SCADA and network data. So we've done a lot of work in the UK, and it's one of the reasons we're actually here in Singapore, is to share some of that learning here as part of SU and within the network here. But what we've been working on and in the UK has been on an 9-year journey on this, is opening up energy data within the sector. So how do network operators share data with other networks, with the transmission, with market authorities, and how do they do that securely and with a high level of trust. So one of the things that we've been working on a lot is that data sharing infrastructure. That's a report that was published and a framework that was published in March of this year. Happy to share that, a link to that following this presentation, and I'll send that over to Johnny to distribute. But that's one of the areas that we've been focusing on is how do you make that data available to these solutions so that they can then start to reap the benefits, because you have to trust that that data is being used. In many instances, energy data is incredibly sensitive because it exposes a lot of consumer behaviors. So if you go to too granular level, you can really start to identify what people are and aren't doing. So for example, we have a living lab in the UK with about 6,000 homes, and we've had to work very closely with some of those homes because they're worried that that data is going to be shared with like the Department of Work and Pensions, and so that, you know, people on benefits might be exposed for going to work on a regular basis, that they've not shared with the government. That all of these things around data become incredibly sensitive, and that's something that we've worked quite hard on in the UK, and we're keen to take that learning further into other markets as well.
Yeah, so talking about markets, I was just thinking this is very niche. I mean, a lot of our developing member countries is not even at the baseline to be able to adopt these innovative solutions, right? So have you done some kind of assessment of readiness for certain markets to be able to adopt these solutions?
So that's the very first thing we do is look at the market and look at its readiness for adoption. And in some instances, what we will look for as well is there a possibility for leapfrogging a journey? So you know, some of the more developed markets have gone down a certain path, but they've made mistakes along the way. So is there a way to bring in the technologies, bring in the solutions earlier, so that they're able to avoid some of the challenges, so they're not necessarily building a grid for a you know, large power generator, lots of users type scenario, so they've got that flexibility. So we're working in markets such as Kenya, where they're trying to grow out their grid. Their priority isn't efficiency, it's energy access. So how do you access power? How do people access reliable power? So that's their need, that's their priority. So how do you start to bring the right innovations in to support it? But that needs base, that understanding of where they're currently at on their journey it's where we start. We have to, because otherwise you risk bringing the wrong solutions into the market, and you're not going to have any impact doing that.
Yeah, just an example, you know, islands in the Pacific, for example, some of them are going into smart energy systems, but they also have, you know, very insufficient digital connectivity. There's a problem with ICT. So, I mean, there's the need, but there's a lot of other challenges that they need to address before they can even leapfrog.
Yeah, absolutely, and we see this where, and I'll use the UK as an example, which might sound a little bit odd, but we've done quite a lot of work with digitally excluded in the UK, and understanding what that means. So as you start to move to a digitized space, how do you include everybody into that journey? Because if you just do it, you know, half the population or however much population gets left behind, and then that doesn't help anybody. So again, coming back to that need and coming back to that priority and of where they are on the journey, it makes sure that you're bringing appropriate solutions in. So in India, in some regions, we brought in various pieces of mobile power technology, so that they were able to bring in and out solutions into more remote parts of the country. So there was various pieces that we did. It wasn't just smart grid, it wasn't just smart technology, AI. It was something, you know, it was almost something as simple as a battery on wheels. I'm dumbing it down a little bit to my level, but that's effectively what we were working on, because that was the right solution for that part of the country and that part of the marketplace. So again, going back to that needs assessment is critical, because otherwise you don't create the ecosystem, you don't create the growth of innovation.
Would you have this a list or this report on the readiness of some countries or DMCs?
I would have to dig around to see what I can find. We've done some work depending on target markets, so they might be a little limited at the moment. Most likely, the one that most recent would probably be Kenya. That's an area that we've recently started to engage with, but I can see what we can find and start to look at that. It is one area that we've been starting to try and evaluate in a bit of a clearer way and articulate. And actually, I would appreciate the opportunity to speak with some of you guys on that bit further, because it's all about that digital readiness. So what does it mean to be ready to adopt a digital technology? What do you need to have? And you know, our team here in the Catapult would be really interested to get to understand that a little bit more, so we can build out a reliable framework for evaluation that doesn't just think about the developed markets. Like there's so much more that we could do with this, but we need to understand it. So I'll coordinate with Johnny, but it would be great to have some input on that from you guys as well.
Yeah, we have several TAs that could actually benefit from some of these solutions, just incorporating some of this thinking into it. We have an innovative grid control technology, regional technical assistance covering Cambodia, Tajikistan, and Uzbekistan. And the other impact there is that, of course, there's a Central Asia power system where you have integration as well as trade of energy across Central Asian states. The same is true with Southeast Asia, particularly, you know, Laos, Vietnam, Cambodia. There's power trade going on, bilateral as well as, you know, multilateral among these countries. So it'll be important to understand what applications these can provide to the grid operators, or even to regional grid operators. And we also have another TA on the battery energy structure, Vietnam, Cambodia, and Mongolia. And we have other you know, energy projects there that also impact the grid. And we are also looking at a lot of vehicle to grid integrations, or vehicle grid integration type of projects in Southeast Asia, particularly Thailand, and also in the Kyrgyz Republic. So there's so many applications that need some kind of innovation around grids, around you know, monitoring, and even AI tools. So you know, we'd love to understand that.
Yeah, and the other thing that we've seen, particularly with vehicle to grid, is one you raised, but a lot of these innovations and a lot of these challenges and the programs are also a people challenge and a behavioral challenge. So I often refer to, when I'm presenting, about the soft squishy bit at the end of the line, which is you and me, and the behavior of people is, you know, once you start to depend on that, you need to be really sure how people are going to behave. And that varies from market to market, country to country, city to city, countryside. So when you look at B2G, you know, how are they being connected to grid? How are they being, when, how often? You know, all of those social aspects start to play in as well beyond the technology. It's a fascinating area to explore.
Thank you. I mean, I'd love to talk some more, but
I come out to Asia quite often, so I would love to make some time to further this conversation.
Yeah.
Yeah, I'm very happy to be the intermediary there as well, if that would be helpful. I am conscious of time. We have run ever so slightly over, but thank you, Andrew and Leo, for your contributions today. And if anybody's got any further questions of both our presenters, please do send them to me or to colleagues in the team, and we'd be happy to pass them on and get some additional answers for you. But thank you very much, everybody, for joining. I will bring things to a close there. I hope this session was useful.
Thank you.